Welcome to MongoDB lecture. In this lecture, we are going to go into the details of MongoDB and see how we can use MongoDB to read, write, and update our record in a database. In today's lecture, we will be covering different concepts of the database, and we are going to see how MongoDB can be used to perform different CRUD operations, and then we are going to discuss pros and cons of MongoDB together with its comparison with similar technologies, and finally an installation guide. Now we'll start with the basic concept of database. Now, what is database? So database can be seen as a collection of electronic records that can be used to process information and generate insights out of it. There are two types of databases, relational databases or relational database management system. These are traditional databases which are also known as SQL databases. Most of you are familiar with the SQL Server database or kind of MySQL, which store information in the form of tables. Other type of databases are non-relational databases, which are also known as NoSQL databases. These include MongoDB, CouchDB, Cassandra. These are databases which store information in the form of documents or columns or different type, and they don't have relationship between different information stored in them. We will go into detail of each different types of relational databases in the next few slides. In terms of history, so NoSQL databases emerged around in mid 2000s. During that time, internet was getting a lot of popularity, and most of the systems, applications, and companies were going online. So big companies like, for example, Google and Amazon, they were facing problem because many people were trying to access their systems and try to store their data. So the traditional databases that they were using, for example, MySQL or relational databases, they were not able to handle the amount of data which was being generated. So in order to address this problem, they come up with their own unique solutions. For example, Google come up with this big table databases, and Amazon had their DynamoDB DB solution, which stores the information in a kind of a non-relational format and in a distributed format. This idea of storing the information in the form of distributed and non-relational format caught attention of many other companies, and they started developing their own solution. And as you see now, there are many solutions available for NoSQL databases, which can be seen as kind of more than 200 solutions are available. And here are some of the big examples which are commonly used. For example, Cassandra, MongoDB, Hypertable. So there are a lot of solutions are available for NoSQL databases, which started in mid 20s. So these NoSQL databases, they don't have any unique definition or a kind of fixed definition for them. So however, these NoSQL databases are defined by a certain characteristic. For example, so in terms of scalability, there are two types of scalabilities: vertical scalability and horizontal scalability. So vertical scalability is used in a traditional system where if you want to improve the performance, or if you want to increase the capabilities of a system, of a database, what you need to do is you increase the resources available to the system. For example, you have a server on which the database is running. So if you want to improve its capacity, you add a new resources. For example, you add new storage hard drives in the server, or you can add more RAM to the server, or improve the processing capabilities. So this is called a vertical scalability, where you try to improve or you try to increase the system's capabilities in a single machine. However, this has a limitations, because physical limitations, because you cannot add resources infinitely. The other type of scalability is horizontal scalability, in which the system is not composed of one server. Rather, there are multiple servers connected together in the form of cluster, and if you need to add new resources or more resources to this database, all you need to do is add a new node to this cluster and its storage capacity will increase. Since these solutions are stored in the form of cluster, so it adopts a unique kind of storage mechanism. Not everything is not stored in a one server, but rather there is a distributed storage. So some files are stored in one node, some files are stored in different nodes. So the whole information or the whole database is scattered around multiple nodes. So the information stored in these NoSQL databases are non-relational, which means that there is no concept of relationship between records. As compared to the relational databases where all the records are stored in tables with columns and rows and they are linked with each other. Here the concept is that each record is unique and it does not have to be linked to any other record. If you want to store information related to a record, it should be aggregated together and stored as one object. NoSQL databases are schemaless, which means that you don't have to follow a specific structure when storing information in these databases. To see it concretely, in traditional databases, you have tables, and each table needs to be created beforehand, and all the columns need to be defined before you start adding data to these tables. So you have a rigid schema already existing, and you must follow this schema to add the data to this. As compared to the traditional one, NoSQL database allow you to store information in the form of, for example, JSON objects or XML objects, and there the number of attributes in these objects does not have to be consistent. So the user can just add, for example, an object with, for example, the name of the user, but in another record they have a name of the user together with their address also. So that's totally possible with NoSQL databases. So you don't have to follow a certain schema to add databases. However, when you are trying to read the database, then you need to know how the data is stored so that you can retrieve it in a correct format. That's why NoSQL databases are also called schema on read databases. Due to this schema-less approach this NoSQL database follow, an advantage comes, which is that so the information which is missing does not have to take space in the database. For example, if we compare them to the traditional database, let's say we have 5 columns in a table, and if you try to add a new row and you have information in 4 of the columns only, the 5th column will still be taking space in the database. Whereas in NoSQL database, since you have this objects, or since you have this schema-less architecture, so the missing information is totally skipped. It does not take any space. Thus, the storage is very optimized in NoSQL databases. And finally, most of the NoSQL databases available these days are kind of open source, so you can directly customize them according to your need. And they are also, since they are open source, they are constantly being updated and improved by the community. So they are fastly growing and they are very stable systems. In NoSQL, the different kind of solutions which are available can be classified into 4 main categories. So first are key value store. These are databases which store information in the form of key value, as their name implies. So you have one key and the information related to this key is stored in the value. So these are kind of the most simplest and easy to scale system where you have key values. A value can be a complex object which can have further keys and values in them. The second one are the column based storage. As compared to the traditional relational database where those are commonly called row-based solutions. So the column-based stores or column-based NoSQL solutions store information in the form of columns. So the document store are kind of third type, which stores the information as one document. The document can be, for example, of type JSON or XML. So you store information as one object of JSON, as one object of XML. So, and finally, the graph stores are kind of unique SQL solution which stores information in the form of graphs. So they are nodes and edges available to you. These kind of solutions are good for storing information which has a relationship between them. For example, let's say you have a data about social connection on some social media, so this kind of graph store solutions would be ideal to store such an information. So here are some of examples of each type. For example, key value store, Redis is very kind of popular one, Amazon DynamoDB. Column based, the Cassandra and Hypertable so is used. HBase is also used together with Hadoop solutions, which is a kind of big data solution. MongoDB is a document based solution which we will be discussing in detail in this lecture. And for example, for graph based NoSQL solution, Neo4j and OrientDB, these are kind of solution which are available for you to use for different types. Now in the next video we will be going into the details of MongoDB.